Welcome to the last video on Section 6, Multi-Node Testing. In the previous video, we tested the FSM actor. In this video, we will take a look at multi-node testing, which among other things can be used to test Akka cluster apps in an almost real setting, with real networking involved between the JVMs. Here, we will get a quick introduction to multi-node testing kit, and we'll discuss the main parts on it. And finally, we will implement multi-node test examples. We'll be running the tests on the same physical machine, so this style of testing is most often referred to as multi-JVM testing, on the same machine, many JVMs, as opposed to the multi-node, which refers to many JVMs on many nodes in the network. The interesting thing is that the API is exactly the same, and we can decide later on where to run these tests. Let's head straight into it. Before we start, let's answer the important question. What's multi-node testing? Multi-node testing means we want to run coordinated tests on multiple actor systems in different JVMs, potentially even on different hosts in a network. This means you want to actually execute a test on different JVMs at the same time. First, let's discuss the main parts in the multi-node testing kit. We have three main parts. The test conductor is the basic part of the multi-node testing kit. It is used to coordinate the nodes participating in the test. The multi-node spec is a convenience wrapper for starting the test conductor and letting all nodes connect to it. The SBT Multi-JVM plugin is an SBT plugin that starts tests in multiple JVMs, possibly on multiple machines. Let's start coding. First, we need to prepare our project for multi-node testing. We will add SBT Multi-JVM plugin in the plugins.sbt file. Then, here's our build.sbt file. It looks different now because we defined some additional settings, such as compile multi-JVM tests by the test default compilation, execute multi-JVM tests by the default test target, and merge the multi-JVM test results with normal test results. Now, let's revisit our worker actor that is a remote actor from the first video in Section 4. It was handled using work messages. We will make it reply to the sender with done message as well. Now, let's start writing our tests. Our multi-node tests are located in the src/multi-JVM directory. We will create our package under this directory. Then we will implement multi-node tests in 3 steps. Define multi-node configuration, then define the basic test trait, and finally, write our tests. First, we need to define our multi-node configuration. In this configuration, we define our nodes and the role for every node. Let's say we have 2 nodes. One of them is a node 1, and another is a node 2. Second, we will define the basic trait for our tests. Let's name it Basic Multi-Node Spec, and this trait will extend multi-node spec callbacks, flat spec like, must matches, and before and after all. We will override the before all function to call the multi-node spec before all function, and override the after all function to call the multi-node spec after all function. Finally, let's write our tests. Let's define the multi-node sample class that extends multi-node spec, basic multi-node spec, and implicit sender. The first thing we need to implement is the initial participants function, which defines the number of members in the Akka cluster for starting the test. So let's say it is equal to the role's size. Now, let's write the first test case. In this test case, we will need to make sure our test waits until all the nodes start. So we will use the enter barrier function, which takes the barrier name. This means the test conductor will wait until all the nodes start up. Let's write the second test case. In this test case, we need to start the worker instance on node 2, and on node 1, we will find a worker reference and send work message for it. And of course, we want to make sure node 1 will find a worker instance after it's created on node 2. For this, we will use barriers that come within the multi-node test kit. Let's imagine a barrier is a point. The node may be doing some work before this point or after this point. But the important thing is, no one crosses this point until everyone has arrived at it. And this is the responsibility of test conductor. Let's start. We will use the run-on function, which takes a node name and block of code to run it on the node. In node 2, we will start an instance of worker, and this node will set enter barrier to deployed. On node 1, after all the nodes have reached the deployed barrier, we will define a worker using the actor selection, and then we will send a work message for it. And finally, we expect to receive a done message. And after our code runs on every node, we will reach the finish barrier. Now, let's define our test classes that will run on the node on a different JVM. So we will add 2 classes. Every test class must end with the multi-JVM followed by the node name. And these classes will extend the multi-node sample class. Let's run our tests. Great! You can check the full documentation from here. At the end of this section, we have learned how to test the actor in different styles. Then we tested parent-child actors, and finally, multi-node testing. See you in the next section, where we will work with a new feature called Akka Stream. Join me there!